Hi, everybody, and welcome to today's Executive Q&A. I'm Cynthia Weishart, editor of Sound and Video Contractor, and I'm joined today by Ralph and Brandon Heinz of Renkus-Heinz. Today, we're here to talk about the company's newest innovation, OmniBeam. This is the configuration software that's designed to democratize beam steering. This design that they've come up with simplifies deployment of this complex and powerful technology, and it's intended to bring it to a wider range of applications and budgets. If you're a veteran with beam steering, this software is meant to give you back time by simplifying the process with a really simple, innovative GUI interface that virtually automates the process. I know it's kind of a cliche about GUIs, but you'll see this is truly the case here. We've linked in the article, accompanying article, to a great short tutorial that's going to show you in detail, and where you'll also see that OmniBeam can be further configured and detailed and customized if that's what you need. Now, on the other hand, if you're new to beamforming, if it's something you've been interested in but felt it might be out of reach or too complex for your clients, this is an opportunity to get into this facet, really important facet of audio, and grow your business in that way and serve your clients' needs better. So over the next few minutes, we're going to get a high-level view of OmniBeam and also take a little chance to spend some time with one of the first families of audio, the Heinz family. I know for a lot of us in AV, it's really great to work with those companies that have that, generational passion. And also, I know for some of you, it's a bonus to work with companies that manufacture in the US, which Renkus-Heinz does right here in California, where I am. So let's dig into this new technology. Ralph, I'm just going to start with you. Your father co-founded Renkus in 1979, and since then you've brought a lot of engineering innovation into the company. I know you've developed several patented technologies. Can you just take us into the Wayback Machine for a minute and give a little background on the emergence of beam steering and why it was important and where it came from before we got to now?
Okay, certainly. Um, my early work with Renkus-Heinz had to do with basically acoustic control of wave fronts through horns and waveguides, and as a result, we came up with our complex conic waveguide topology, as well as a coentrant waveguide technology, where the mids and highs now all emerge from the same uh, point within the horn. And as a result, we were being known in the industry as the accurate coverage people. And in one of my uh, AES presentations, I was approached by Johan van der Werf, a Dutch engineer at the time, and this was probably back in the early 2000s, I would say. And he basically wanted to share with me his latest developments on beam steering. He, by the way, was the one who implemented the first beam steered arrays in Schiphol Airport that were actually where the delay for the amplitude shading was all done analog. So this was done with bucket brigade chips and a spreadsheet that he used to determine what the delays should be, and implemented manually and analog. So and if you've seen them, I believe they're still there. You will see like columns of Bose 101
Yep.
enclosures being logarithmically stacked on these long poles in order to get intelligibility in these in the very reverberant spaces they were used in. And he shared with me some recent. So that was the really, I think, the world's first implementation of this technology, and he wanted to work with us as to take it to the next level, let's say, to actually commercially integrate it. He had already been working with Garrett Duran and IntelliVox, and they came up with some of the first beam steerable columns, based on modern electronics at the time, but they were sort of, or he felt that they were relegated to the sort of the speech end of application, and he saw us as perhaps being able to bring this technology more into the concert sound and or performing arts venues, which would also benefit from improved signal to noise ratio within their venues. And so that's where the thought he shared with me some papers and some recent innovations that he came up with a side lobe free algorithm, which is basically what he was uh, selling at the moment.
Right.
And we were a potential purchaser of the algorithm. We worked together for a couple of years. In the end, we parted ways because we couldn't come up with a suitable business agreement between the two parties. But we were determined to bring this technology to fruition on our own, and that's what we did.
Right. So in the beginning, it was very complex, very groundbreaking, and something that took a lot of development on Renkus-Heinz's part. So, Brandon, as the product manager for OmniBeam, what changed that meant that this could go from something that the mad scientists are working on to something that could be as simplified as it is in OmniBeam?
So OmniBeam it wasn't so much a fundamental change at Renkus-Heinz so much as us continuing to evolve our technologies. We always are striving to make technologies easier to use and more accessible. And because of that, we realize that we can do better in our beam steering domain. Some of our original technologies became easier to use when we first launched our UniBeam algorithm, and then again became easier to use when we came out with the room geometry optimization for our UniBeam. And through those developments, we quickly realized that this can become something that is just as simple to use as point and shoot loudspeakers while giving the user or the integrator or the contractor access to the same ultimate end result and quality that they're after from a beam steered sound system while dramatically reducing the amount of time and effort required to get those results. And that's really where OmniBeam came from.
Right.
Well, a little history, if I may.
Yes,
Our
please.
our initial implementation of beam steering was around an algorithm called constant lambda, where the where we maintained the height of the array was proportional to the wavelength. So if we wanted to achieve a let's say a 77-degree beam, the height of the array needed to be, I forget what it is, 10 times or 14 times the wavelength at that frequency. So let's say at 1 kilohertz to achieve a 77-degree beam, we needed a 14-foot tall array. By 2 kilohertz, we only needed a 7 foot tall array. By 4 kilohertz, a 3.5. So we were using low pass filters. We were reducing the frequency at which each driver was used to, depending on how tall how much directivity we were trying to achieve. And by doing that, we had to create a table of a lot of beams for each configuration. And we learned very quickly that one beam does not cover a venue. You could either use it to cover the back of the room or the front of the room, but because of the shape of these constant lambda beams, you would need to superimpose the outputs of two or three or four to actually achieve really good coverage in that room. And that experience is what led us and drove the Unibeam and OmniBeam developments, because we saw that while one beam is easy to point and shoot, it really took a little more work to address the performance of the array in the throughout the entire venue. And after years of experience, we knew what we needed to do to get those results, and basically got an asymmetrical multi-beam performance out of a single beam. And that's the the trick, or the benefit now of Unibeam and now OmniBeam.
Right. And so what does that do for the listener, or the experience of the person in the room? How does that change things for them?
Well, it's at the end of the day, the goal of any sound system is to provide an optimal experience for as many seats in a venue as possible. Because the reason why we're putting these sound
Same
systems in
experience.
isn't for any other reason except to deliver an experience to the person in the seats. And using OmniBeam, we're able to make sure that every seat in the house is the best seat in the house, because you have consistent coverage, consistent sound pressure level, and consistent tonal balance across the entire audience area with this new algorithm.
Right. And that would hold whether it was for intelligibility of speech or for the experience of music.
Correct.
Both together. So I think for some of our listeners, a lot of us know these terms, but I think let's back up just for a second and talk a little bit about why those variables are so important. Why is that consistency important, and the sound pressures? Just a little background on why.
So I think we all can kind of think of a time where we went to a concert or to a hall and sat in a seat that didn't quite have good audio, whether it was too quiet in the back or way too loud in the front. And we kind of leave that experience kind of disappointed. And being able to deliver an audio system that makes sure that the sound pressure level and frequency response is the same at all seats, it means that everybody, or as many people as possible, have the same audio experience. So nobody has to go home feeling like they didn't get their money's worth from a concert, or nobody has to leave a church service wondering what the message of that particular sermon was. You can make sure that everybody hears what they need to and has a good experience because of that consistency.
And Ralph, I remember you saying that a lot of times beam steering is thought of as something to solve a bad room, but that there's tremendous potential for it to enhance a good room as well. Is that correct?
I certainly think so.
Yeah.
Beam steering for everyone.
So for our integrators, they can go to their end users and their clients, and they can just really make this case that it's about the experience that, those people are going to be able to give to their constituents. Right. So let's also talk a little bit about the business side of it. So you're an integrator. You have to respond to requests for proposals. You have to go on site and manage the room. So let's talk a little bit about whether OmniBeam can help the integrator at that initial time when they're doing design, specifying systems, and just kind of preparing to give the best experience. Is that relevant? Is OmniBeam relevant to that part of the process?
Oh, most definitely. It in the same way that it helps simplify your time on site when you have a system installed, that same time-saving benefit is there when you're doing a sound system design or a simulation. And that allows you to get to a point where you are confident in your system design much faster, enable you to turn around those jobs faster for your clients, and have the confidence to know that what you're seeing in simulation is going to match what you find out in reality once you put the system into the space.
Right. I mean, our Iconics arrays need to be simulated in a software program, typically Ease or Ease Focus, and by having uploaded and simulating proper coverage in the room, we can actually, even in rooms that don't exist yet, we can give the contractor or consultant a good feel for the type of speech, the STI numbers they can expect, the alcons, the consistency of coverage, front to back, left to right, and so it's a good confirmation that the technology will work for them and provide the results they need.
Right, and then I was struck because we've all been on site. I was a theme park designer, and you all have been on many sites. You know how sometimes you're on site and I don't know, the stub up's in the wrong place and the speaker has to move or the room bounces in a way that you didn't really anticipate or all that types of things. So you have your design parameters in place, but then you're on site. So am I correct in understanding that OmniBeam can support that, any adaptations or changes that need to be made then?
Oh, absolutely. It in the same way that it helps to speed up the initial target that you're going after. If you find that you're getting a reflection off the back wall and need to kind of reduce your coverage to reduce that slapback echo, OmniBeam's user interface makes it very intuitive to make those adjustments that you need to while you're on site. All with a huge added benefit of not needing to physically adjust your loudspeakers. It takes a few mouse clicks to adjust your coverage to help optimize for a space that may have changed or optimize for different reflections that you might be experiencing in the space, optimize for gain before feedback with the microphone system that's in front of the loudspeaker, all while doing it very quickly and very intuitively with this new user interface and user experience that OmniBeam delivers.
Yeah, I mean, imagine the difference between hanging a speaker at 35 feet or so above a sanctuary and then realizing that, oops, it really needs to be aimed another 10 degrees down. Whereas we can do that now. That's a mouse click for us,
Mm-hmm.
as
Fewer people
opposed to
on
a
ladders.
lift rental for the conventional system.
Yes, exactly. Is there anything else that you guys wanted to bring up? I want to say to everybody that I would advise to take a look at this little tutorial because a lot of what has just been mentioned, you'll be quite impressed to see how easily you can adapt your parameters and how quickly you can get data back from that. For the two of you, is there anything else you want to say? Are there trainings people need to know about? Anything else they need to know if they want to get going with this and take it the next step?
Yeah, we have resources on our website that will allow you to dive a little bit deeper into OmniBeam and some of the more advanced features that we have available within the algorithm. We also have the tutorial that you had listed. But for the most part, we are fairly confident that all you need to do is open the software and play a little
Yeah.
bit to figure it out. It's not something that's overly complex. And if you have any questions, we have a wonderful support team that is always ready to take your phone call and answer any questions that you have.
Okay, so you can confidently say that we can expect beam steering to be more widely deployed in the future based on, in part, your guys' contribution to market.
Well, our Iconics systems sound as good as the rest of the best.
Yes.
So there is no uh, sonic hit for beam steering. I think that there is a perception in the marketplace because of some of the earlier systems that preceded us that there might be a hit in sound quality as a result of all this DSP that's going on. But it's actually the opposite. In fact, because of our improved signal to noise ratio in any room, whether it be bad acoustics with lots of reflection or a well behaved uh, uh, typical auditorium kind of thing, by having at least a 3 to 6 dB benefit of improved signal to noise ratio over a conventional system, line arrays included, we will typically sound as good or better than any other alternatives for that venue.
Great. All right. Well, thank you both for joining me today. I'm glad we could make people aware of this new possible tool for their toolkit and this new way to bring better experiences to their customers and to their business. Thank you both.
Well, thank you, Cynthia, for the opportunity. We appreciate it.
Yeah, it's very, very nice to chat with you and spread a little bit of the gospel about good beam steered loudspeaker technology. So thank you very much for all your time today.
Yeah, thank you both.